Hey, this is Brock Lemiers, and in this video we're going to introduce the Arduino single board computer and get started with installing the software and writing our first program. All right, so let's begin with what is an Arduino. An Arduino is the name of this open source computer system that's implemented on a single board. And when I say board, what I mean by that is board refers to a printed circuit board, so that's like the little card that you see here. And printed circuit means that it basically you print through a process of printing and photolithography and etching, you can put wires onto this board. And so this is how you make all modern electronics. This is how you mount all integrated circuits to talk to each other. So motherboards and the boards in your families, in your phones. And so this is a single board computer. And what that means is that on one board, you have everything you need for a computer. And so that's going to be the central processing unit, which understands how to execute all the instructions that you give it, memory to hold all the instructions that for your software you're going to write, memory to hold variables that you'll use temporarily during a program, and then also input and outputs. So little pins where you can drive LEDs, you can read from voltage sources, or you can drive motors. Okay. What makes this an Arduino is that it is implemented on this Atmel chip right here. So all those things that I talked about are on this chip. And then the Arduino is also a standard for the board size in addition to the connectors that you see right here. So the connectors are common so that you could build another board that plugs into it, and those boards are called shields. Now, the Arduino that you usually see is from the actual place Arduino, but since it's open source, other people can make boards that are pin compatible and are cheaper. And so this is what we're going to use in this one. This is from ELEGOO something or other. It's like a cheapo one. It's got the same chip on it. It's got an Atmel on it, and we can use the same development environment for it. And it's just a little bit cheaper than this one over here, but they're the same thing. Okay. All right. So if you look at what's on here, the chip right here has everything: the CPU, instruction memory, data memory, and I/O. And then the I/O pins are actually brought out to these connectors. So you'll see these little labels, and we'll go through this throughout this video series. But you'll see labels on here where it's like, oh, these are analog pins, A0, A1, A2, etc. And these are routed to pins on the Arduino. So if you wanted to read a voltage, for example, you would plug in a wire right here and put your voltage into there. And then up here you have your digital pins, and digital just means they're either ones or zeros. A 0 is going to be a 0 volt, a 1 is going to be, on this system, I think it's a 3.4 volt, but it basically is either 0 or 1, and that's what you use to do digital things. So drive an LED, drive a motor, communicate with a computer. And so the pins that are digital on the Arduino are routed up to here. Then on this board you have a couple other things. For example, the USB connector. So you've got this honkin' USB type B connector on here, and you can plug this into your computer, and that's how you actually develop software and download it into the Arduino. So what's neat about this is that you send your software down here and put it on the Arduino, and it actually has memory on here that doesn't lose its contents when you power it off. They call it non-volatile memory. And so you can download your program, unplug your USB cable, and this thing will hold your program. So if you didn't want to, when you do your software development, you can actually power the board from the USB cable. So all you do is just plug this into your computer, it gets power to power the board, and then you develop your software, download it, and you're done, and you can run it. And when you have the power or the connector connected to the USB cable, you can actually send messages up to your computer and look at them. So you can print hello world, or you can send characters down, and so it's actually really useful during debug. If you chose not to have a cable connected, like you wanted to put this on a robot and not have it tethered to anything, you can power the Arduino board from this little jack right here, and this takes in 7 to 12 volts, and this is for like a bunch of AA batteries connected in series. So that's the Arduino that we are going to use. And so what makes an Arduino different from a regular computer is that regular computers, when people think about that, they think about workstations or laptops. And those are meant to be general purpose computers. So they run an operating system like Windows or Mac or iOS or Mac OS, and you can launch any application on here, Word, Excel, Chrome. You can write applications for it. And so it's really a jack of all trades that is meant to be more powerful and more general purpose. And the reason and it takes more resources to be general purpose. So they're larger, they have memory that comes in sticks that you plug in, they have hard drives that you need to plug in with cables. And so it's just a little bit bigger, but it's meant to be very general purpose. When you think about an Arduino, it is what's called an embedded computer, and it is usually used for one specific task. So these are things that are going to be found in like thermostat, or in a TV, or in like the mirror controller of your car, a gaming console. So they're little computers that are what we call embedded within other devices, and they're used to basically do like dedicated control. And so these things are everywhere. There's far more of these embedded computers in the world than there are general purpose computers. In fact, there's like 30 billion of these sold every year compared to like 300 million of general purpose. But that's what makes it different, is that you're not going to run Windows on this. You're not going to run, Android on this. You're basically going to write a very simple program, download it, and then it sits there and does specific tasks. Usually they're like read from a sensor, react, read from a sensor, react, print out something, and you're off and running. You're not going to plug a keyboard or a mouse into this thing. It's very task specific. Okay. Now, why are they popular right now? The reason is abstraction of the computer hardware. So Arduino has created this integrated development environment, or what we call an IDE, which is incredibly simple. Like you can develop programs for the Arduino without understanding what a computer is. You don't need any high-level programming language. You basically just open up this very simple GUI and you type in these statements that are almost always provided to you by Arduino on their website, and the thing will actually work. So they've abstracted what's actually going on underneath the hood of that Atmel chip to the point where you can do this in like elementary school. You can put this up and say, move forward, print out something, make an LED blink, and abstraction is what makes this so powerful. Now, we are going to learn about the Arduino and use this abstracted IDE, but at the same time, we're going to be trying to figure out like what does it actually do and how can we use it in real applications. Drive an LED, how much current does it take, et cetera, et cetera. So that's why it's so popular, is because it's so simple, but the simplicity comes from the abstraction. And then what happened is that once people realize that you can like program these things so simply, people started making all these shields for them. So this is an example of a shield. See, notice it's a board that's like got the same outline as those boards we were looking at, but this one has an LCD on it, or a display, and this can plug directly on top of it. So people started making all these shields that you could plug onto it, and you could have buttons and LEDs and LCDs and motor controllers and all that sort of stuff. And so then it just kind of took off, right? And so everybody, you can just find anything and everything for an Arduino. Okay, so how do I program an Arduino? What we need to do is go get the software. Now, when you write a program, you write it in a high-level language. You say if, else, loops, and stuff like that. And you need to then do a process called a compile. So a compile converts your high-level program code into ones and zeros, or what we call an executable, which then you download into the memory of the computer, and then it runs. If you are on a computer, let's say you're on Windows and you're running like some C or C++, and you compile it and you run it on the same computer, that's just a regular compiler, right? But when you write software on this computer and you compile it for a different computer, and in this case that would be the Arduino, we just call that a cross compiler. And the reason that's important is because you're developing on your laptop or workstation, the program you're creating actually can't run on your own computer. It's developed and compiled to run on this one. So the only way to actually test it is to actually download it. So then what we'll do is we'll use a USB cable to go ahead and program it. Okay, so let's take a look at what we have in our little kit. So we're using this super cheap robot kit called the Smart Robot car, and this is for children. I mean, but we're not just gonna put it together like a remote control car and use it. We're gonna try to figure out like how everything's working. So I'm gonna open this box here and take a look. So what I'm actually looking for is I'm gonna come right in here and I'm gonna grab this little fella right there. And in one of these boxes is the Arduino. So let's go ahead and take a look in here. There it is. So here's the Arduino. I'll go ahead and back some mess. And I look at this thing and I open it up And I'm like, hey man, that's pretty cool. So there's our little buddy. Okay, that's our little Arduino. And there's the chip, the Atmel chip that has the computer on it. And then you can see all the I/O just like we talked about. And so what I first need to do is I need to install the software, but I'm going to connect this to a USB cable. So I need to get my USB cable out too. So I think it's in this one. Let's see what we got here. So I'm coming along and I'm like, give me the cable, not in that one. No worries. There's only one left, right? And let's go on over here. And there it is. Okay, nice cable. Yeah, it's a good cable. All right, so those are the only two things we need right now. So let's go ahead, put this back, and get this out of our way. So take that, stuff that somewhere. Okay, so now here is a little bag that it came in, and here's the Arduino, and you're like, what's the bag? The bag is an ESB bag. So if you have a cat or you walk across the carpet and get charged up and you zap electronics, it kills them, right? And so one of the things you can do is put it in a bag whenever you walk across campus or do anything, and then that way the ESD doesn't build up. Another trick is to always grab the USB cable, the USB connector that's ground. So if you are charged up, been petting cats, you go ahead and grab that, and hopefully all the energy that you have on your hand from petting a disgusting animal is zapped into the ground plane, and you won't actually blow that thing. Okay. All right. So what we're going to do right now is we are going to install the software. So here's our cable. This honker right there is USB type B, usually used primarily for printers, but we also will use it with the old Arduino. And then this right here is type A, and that's usually what plugs into your computer. They actually give you another cable if you want to use USB micro, but we're not going to use that. Okay, so here we go. So now what we're going to do now is let's go out and get the software. So I'm going to go out to a website called arduino.cc in order to get this software. So let me bring up a web browser. Okay, so now I got myself Chrome here, and then I'm just going to go arduino.cc, and it autofills. But let me get back to the Arduino. So you come out to the Arduino page, and I'll zoom out a little bit. And this is basically the open source page for this stuff. And you see all this stuff. Buy an Arduino, learn about it. Everything you ever need to know about an Arduino you can find here. You can find all the little built-in software routines that you can download, documentation. This is going to be where you want to go to learn about, like if we have a function that's called serial print or something like that, you can go figure out exactly what it is. But for right now, what I care about is the software. So I come out to the software and I come down here for downloads, and today we're looking at the latest version is Arduino IDE. IDE stands for Integrated Development Environment in 2.3.3. They're almost all the same, so you just get whatever the latest one is. Choose your operating system. I'm running on a Windows machine right now, so I'm just going to do Windows right there, and then download. I'm going to go ahead and just download. I'm not going to donate anything right now. That was a beginner, blah, blah, blah. Whatever. Okay. So I don't need to subscribe and download. I just want to download. So there you go. Open source, things free. So one of the ways they fund themselves is by taking donations. Okay. So I downloaded, not that big. I go boom, and here we go. All right. So I got this. I agree. Just anyone who uses this computer, whatever. I mean, you're just installing software at this point. No big deal. Okay, so then I say I agree, and where are you going to put it? Just accept the default for it, which is going to be C program files, and it's going to install right now. It doesn't take too long. Okay, so it's done. That did take like 5 minutes. I stopped the video so that I didn't have you sit there for that long watching software install. So it's done, good to go. I'm going to go ahead and leave this run Arduino IDE on, and when I go finish, it is going to launch the software. And it also made a shortcut on my desktop. Okay, so then the Arduino IDE will launch, and this is what you will see. Okay, so it always comes up and it has this blank kind of template code in here. One of the things that happened the first time that I launched it is it spent like 5 minutes installing a bunch of drivers for the USB port, and that allows you to talk to your Arduino and also download programs. So you got to be, in my computer, it had a bunch of admin issues, so I had to log in as admin, all this stuff. So just know that it's going to install a bunch of stuff and it might take a few minutes. Okay, all right. right, so what you have here is a program, okay? Now Arduino calls all of its programs sketches, okay? And that's probably because they're really abstracted, they're really simplified programs, so they didn't quite want to name it a program, but this is what a sketch looks like. You're just going to type in text into here, and the text will be statements that tell the Arduino what you want it to do. Within the sketch, there's two what we call functions, and a function basically is between these curly brackets, and it has a name, in this case setup, in this case it's called loop, and then this mirrors like the C programming language where the void in front of it just means that once you run this function, it's not going to return anything, which we don't really care about. But one concept with Arduinos is that the setup function up here are statements that are only going to execute once. So they do things like set up your program. So if you want to set up the serial cable so that you can talk to the computer, you do it here. If you want to set up an I/O port to be an output, you do it here. You want to set up an a port to be an input, you set it up here. You want to set up constants, whatever. You just things you only want to do one time, you put up here. Things you want to do over and over, you put in the loop. So you're going to have all these different statements, and what you'll do is you'll run through them one by one, and then once you get to the end of the curly bracket, you'll come up here and you'll repeat forever, okay? So we are going to just insert some very basic statements right here, and you don't even need to know what these are. You just kind of learn by typing in various statements, and then
I can go ahead and let this.
You just, So the statements that you'll use, a lot of them we'll give you some of them just to get used to things, and then we'll kind of talk about programming constructs, very, very basic stuff. But a lot of the statements you can go find on the Arduino website, and we'll walk you through looking at example programs, and you'll kind of get the hang of it. Again, this isn't a programming class, it's just kind of to get you used to this whole environment and just basics of programming. So I'm going to do a statement right here that is called serial, okay, serial.begin 9600, okay, and then a semicolon. And what that does is that you can think of it as serial is basically like it's like a library of functions that have been developed for you, and then the dot begin is the function within that library, and then this is an argument. So what this particular thing does is it sets up the USB cable so you can talk to serial monitor. Okay, and that'll all make sense when we're done here. But this text that I type over here is what we call a comment, and it's just basically describes what this statement is doing. And the way you make it a comment is you put 2 forward slashes before it. So that's what these are here too. And comments are very important when you program, because sometimes you just look at a statement and it's like, I don't even know what that means. So then you read the comment and you're like, oh, okay, that's cool. All right, and then you're going to come over here and I'm going to do this. I'm going to go serial.print, and then I'm going to actually print something called hello world, and I'm just going to leave it just like that. Okay, so I'm going to say comment print a message. Okay, all right, so that's my entire program. That's all I'm going to do right now. All right, now I need to think about saving this thing. So what you want to do to organize your sketches is you want to make kind of one folder somewhere that you know where all your sketches are going to be on a network drive or something. I'm going to put my stuff on the desktop. So I'm going to go to my desktop and I'm going to create one folder for the entire class. So I'm going to call this E101 sketches. Okay. And I'll go ahead and save that. And so now what I'm going to do is in the Arduino, I'm going to come in here and I'm going to say file save as. The first, I always like to do a file save as just so I know exactly where it's going. And what I'm going to do is I'm going to come up to that one folder on the desktop and I'm just going to name it something descriptive. I tend to name my stuff starting with a number just so that it's in sequential order when I look at it. But I'm just going to call it 0. Let's go 01 hello. Actually, I always start with 0, so I'm not going to change it. Hello world, and I'm going to go ahead and say save. Now notice I don't give it a file extension. I just point it into this folder and say save, and then it's going to save and it's all happy. Now let's look at what just happened. When I go back into File Explorer, if I come look at my sketches, it actually created a folder for me. And if I look inside of it, there's just a single file called .ino, and that is the entire Arduino sketch, and it's got everything it needs in there to be downloaded. Okay, so what's cool about it is that you don't even need to create a folder for each particular sketch. You just give it a name, and Arduino will automatically create the folder for you and then organize files within it. Okay, so now I've got this thing in here, and I'm ready to kind of think about compiling it. Well, one of the things that happens is that when you compile it, what you're going to do is run a program that takes all these statements and converts it into an executable. But it needs to know what the computer is that you are using to using to run this program. So at this point, what I'm going to do is I'm going to come over here and I'm going to plug in my Arduino. Okay, so I've got this. I've got my USB cable right here. I look at the kind of the marking or the shape of the type B USB, and I'm gonna go ahead and plug it in. The first time you plug that in, it's really hard to plug in, but you'll notice that like lights come on and you can see power on there, and it's like, okay, this is cool, it's getting power. So now I'm going to come back over here and I need to tell it what board and what port of my computer that this stuff is on. So the first thing I'm going to do is tell it what port it's on. So if you go to Tools, Port, you're usually just going to see one available port because Arduino kind of looks at all your ports where like your keyboard and mouse are, and it's like it knows to not download to a mouse. It knows that the only one it wants to download to is something that's on that looks like an Arduino on one of these boards. So it only gives you the list of port numbers that have Arduinos on it. So I go ahead and say COM3, and then what I got to do is I got to choose the board that I want. So I can either do it from Tools Board or I can do it from Select Board. So this one said select another board or port. Once you do this setup, you'll never have to do it again. So it's just kind of the first time you do it. So let me go over here and I'm going to choose Arduino AVR boards. And all I want to do is go Arduino Uno. Okay. So that's going to be the board that I have. So now that's it. I've set up my port. I've set up the Arduino board. And now what I'm going to do is I've already saved it and I'm going to go and I'm going to hit this verify button. So verify is going to check all your syntax and make sure that it's okay. And then what it's going to do is it's actually going to create it's going to give you messages down here about how much memory it's going to take and all that sort of stuff. And then it's ready. It creates the executable that's ready to go. So now when I'm ready to do that, I can go to the upload button and I can actually download this to my board. Now, one of the things that's interesting is if you save this and just hit upload, it'll automatically do the verify step. I tend to always do the verify step first just to make sure that it's cool, and then I go to this. I don't like to like jump ahead. I like to verify, make sure it's okay, and then I upload. Now, if I think about what this program is going to do, all it's going to do is print this text message, hello world, to the computer. So the only way you can see that from the Arduino is to come in here and start this tool called the serial monitor. So if you come in here and hit serial monitor, it'll actually create down here a tab. Oh, and it actually ran. So you have output, which is messages about your compile, and then you have serial monitor, which is the information that you're printing. And this actually downloaded and ran it. No, it didn't download and run it. That was already on the computer because I was doing this before I recorded it. So don't worry about that Brock right there. These are tabs. I know you can't see that they're tabs. There's no like differentiation other than this line, but this is actually a tab. So here's what I'm going to do. I'm going to go ahead and upload this, and it's going to compile the sketch down here. And then what's going to do is it's going to upload it. And then when it's done, I can come over here to the serial monitor and make sure it worked. Hello world. So it printed hello world. Okay, the program that was on the Arduino before printed Brock. This program printed hello world. Now you're sitting there going, how do I know you did hello world? So then I'll come up here and I'll go hello world again. So now let's save that, Control S, and I'll go verify, hello. You can see why people use the upload button right away because when you do it, it compiles it and verifies it anyway. So then I go ahead and do that. It's building my sketch. While it's doing that, I'm going to come over here to the serial monitor and wait for it to run. Hello world again. Notice these are all running one time and they're just printing it to the serial monitor. So at this moment, let's clean this up a little bit. If you wanted to put a line return, what you do is you use these special characters. They're called escape characters. And if I go /n, that means put a new line character, or also called a return. So let me do this. I'm going to say hello world return. And then I'll say hello world. Let's do like hello world 2. 1 and 2. Okay. And so I save that sucker up. I verify it. And now I'm sitting there going, okay, this is kind of fun. Kind of fun. And there's my stuff from before. And I'm like, I'd really like to clear this stuff out. I wonder how I clear the monitor. And it's like, oh, just do that. If you click this button, it says clear output, and it'll clear your thing. Okay. So I'm going to go ahead and download this. I'm going to click on serial monitor and wait. Uploading Hello World. Hello World 1, Hello World 2. Now notice how there's a return in there. It's like, hey, that ain't bad. That ain't bad at all. So this is now your first program that's actually running. It's compiled on your own computer. You download it to the Arduino over the cable, and everything is good. So the final thing I want to do is I want to show you what happens if I come down into the loop section and I do serial.print, and then I say, let's go Brock. And then I'm going to do was here. Okay. And then I want something that's going to be like, I want something that's different because it's going to print this over and over and over. And then I'll come down here and I'll say, so was red. Okay. So here we go. I'm in here and I'm going to go ahead and run this. Now these will print one time, and then this will go boom, 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 and it'll go forever and ever and ever. So this thing is verified. I'm going to download it. I come into my serial monitor. I come over here and I click that to, oh, it's trying to get me back in here. I clear out my serial monitor and now it's uploading and we're almost ready. Here it goes. Look at it. Ooh, baby. So it's going forever and ever and ever. Life is good. Holy cow. You did it. Okay, so this is it. You actually have created your own program for the Arduino. You've actually done a lot. You learned about the Arduino, you installed the software, you got the drivers installed, you wrote your first program called Hello World, and you are off and running, and now you just do more and more and more, and after 4 years, you'll be competent. All right, that's it, and see you.